Hello. Today we're working on a worksheet packet that says methods and meanings at the tops, and it's about a way to approach multiplying binomials. All right. First, top problem said, examine this. How is it similar to the algebra tile rectangles? How is it different? Now, the algebra tile rectangles are the ones like was in the first example up here, where we had one side that's x and one side that's 1. And you had a whole bunch of rectangles, Andy, 2 days ago that were made up of various shapes of putting x and 1 pieces together. Remember that? So how is this the same and how is it different?
Different numbers.
Different numbers. What else?
In both figures, only one box that is a holdover, like no variables.
Only one box has no variables. Okay. And the last time it was a 1. Now we're having the option of some numbers other than 1. So how is this the same as working with algebra tiles? How is it the same as when we were piecing together pieces like this?
You need to add up the area.
Add up the area. What else would you say is the same? Okay. Now, what I did notice is some people took this and went ahead and did area as a product and area as a sum. So let's look at that. Area as product. Area as sum. Now, for the area as a product, you're going to put things into parentheses. Brody, what would be the length of this side?
5. Wait, no. 2x plus 3.
Good job. You can't add them because one has an x and one doesn't. Okay. Chris V, what would be the length of this side? That's the other side. 4x plus 5. That was good. You know that it's going to be an expression. So area as a product is where you're setting up the length and width. You don't have to do anything with it, except you have to find the parts that make the total length of this side. A lot of your work is working with pieces, small pieces at a time, but areas of product, they want length times width, and in most cases it's going to be an expression. Areas is a sum. Andy, what would we get here if we looked at the area of the sum right here? How would we write it? They've already been times for us. I just want to write the expression. What do you usually write first? Because it has the x squared, right? So if we wrote the 8x squared first, I'm going to put plus. Isabel, what would I put second?
You put the
12x. Does it have a buddy I can add it to? So we're going to combine like terms. 12 plus 10 is 22x. And we were able to add those because the variable matched exactly. We can't add it to an x squared. It's a slightly different type of x.
Plus 15.
Thank you. All right. Now, on these ones right here, they said write the area of each rectangle as a product and as a sum. Let's see. I think I'm going to do this. I'm going to make a table to make my life easier, or should I just do each thing next to each other? Probably each thing next to each other is good. So first, as a product, I need 2 parentheses. Brian, what's going to go in the parentheses for this rectangle?
X plus 1.
And
2x plus 3.
good. Oscar, where do you get those numbers? From the square on the sides. Okay, so that's area as a product. Now, for area as a sum, I need to go through the individual boxes and fill in the middle. Martine, what's going to go right here? Okay. Now, if I'm looking right here, I can see the 3, and I have to look across the triangle to figure out what that other side is.
15.
Perfect. Now, if I'm looking right here, I see the X. Thank you.
3x.
No. It'd be 3x if we're adding. For area, we're timesing.
2x squared.
2x squared. So when we're looking at these sides, we're multiplying length times width. Myra, what's going to go in this last box?
3x.
Thank you. All right. Jacqueline, how would I write this expression as a sum then?
2x squared plus 13x plus 15.
Can you simplify?
No, because this has an x squared, this has an x, and that doesn't have anything. So none of those can add any more until somebody tells us what to substitute in for x.
I thought 3x had a square. That's all.
No, we did simplify already by going 3 plus 10 to make that 13x. That's as much of the simplify as we can do. All right, we are working on this packet individually. Some of it is this, some of it is review of the, for each multiplication, sketch an area model. Interesting, because I see a big one here. That'll be fun. All right, and then some more algebra tile stuff. Awesome. This just says multiply. I wonder if they want you to stop doing it with the tiles. I don't know. All right, you're going to work on this packet. Miss Morello will decide. It might be a 2J job to finish what's left, but work, and I'll walk around and answer questions, and here we go. Continue on, my friends.